There's nothing better than no supreme challenge.
No, and it's lemongrass.
No. Yes, she is. Yes, she is.
What happened? Is it wow? Did you practice? Wow. You have to wait. And it has to be louder. Hey Joel, should we get started? Is it time? Okay. No, you have to wait. Hey, so can you believe this is the last week?
No.
Only 4 more days left. So try to work your hardest. Yeah. So what is PWSI? All right, more like it. So many years ago, we started a collaboration with a team from Japan. And so they've been running their own program, autonomous mini race car. Matter of fact, I think later this week, a team from Japan will be here, 3 students and a coach, and they will be competing in the final event on Saturday. So where's the race car team? Are you ready for them? That doesn't sound too confident. All right, and then we also have a team from Italy and a couple of teams from Greece who will be competing, and a team from Syracuse University who will be competing in the final event. So that collaboration eventually led to MOL, Mitsui O.S.K lines being one of our sponsors this year. And so they are sponsoring a remote sensing for disaster response course. And it's my great pleasure to introduce today's speaker, Koichi Kawanaka. Oh, sorry, I'm going to do this right. Koichi Kawanaka-san from. Yeah, he is the CTO from MOL. I believe he's actually from Japan. Came all the way from Japan to give this talk. And if you read his bio, you can see that he's probably worked on almost every type of ship that exists. So he must know a lot about ships. You know, shipping does keep our economy going, right? World's economy going, right? So it's very important industry. So with that, let's give him a warm welcome.
Hi, hello everyone. I'm so excited to see the many youngsters. And my name is Koichi Kawanaka. Today, I'd like to give you a presentation which will take a journey to introduce the wind propulsion system on our vessels. The project name is a Wind Challenger, and the title of my presentation is May the Wind Force Be With You. Yeah, this is an extract of the famous Star Wars film's wording, May the Force Be With You. We just add wind into the title of mine. Yeah. So just let me briefly introduce myself. Koichi Kawanaka is my name. I'm a Chief Technology Officer in a shipping company based in Japan, Mitsui O.S.K lines. We call it MOL. Yeah. And I took a Master of Science degree in a university located in Japan, and I majored in the naval architect, particularly for the hydrodynamics, which relates to the ship engineering technologies. Yeah. I joined MOL almost 30 years back, immediately after I graduated a master course. And I have spent many years in MOL, basically more than 20 years with a technical background. And the recent couple of years, I also spent a commercial activity, marketing and the sales of the energy relevant vessels, which MOL has. So I not only the technical persons, but I so much excited to work in MOL to diversify my career, including the commercial and the marketing. Yeah. And I work in overseas office as well, starting from the Shanghai in the early 2000s, then after Singapore. And I just came back from the London this end of the March. Yeah. But rest of the times I basically stationed in Tokyo because we have a headquarters in the Tokyo office. But I want to say that our company has given a quite wide variety of the working in the overseas offices. And today I'm joining the program together with some of the colleagues working in the US. And particularly, I'd like to introduce one of my colleagues. He's actually the alumni from the MIT. Rachit, join with me. And thank you.
Hello. Okay. Hi, everyone. Nice to meet all of you. My name's Rachit. I graduated from MIT last year. I'm not as smart as all of you. I didn't do engineering at MIT. I went to business school. But I've been working with MOL for the past year. I'm part of their venture fund, which essentially means that we invest in early stage startups in the climate tech area. My background is in mechanical engineering. So I studied mechanical engineering at Georgia Tech and was very interested in like solving for energy problems then. And have sort of worked across the world, Asia, Africa, Europe, India, US as well. During my business school, I want to talk a little bit about like why I started working in the shipping sector. I came to business school with the idea of working in climate, realizing that that's the biggest problem you have to solve for over the next 30, 40 years. And there are myriad of engineering, technical challenges that you have to work through, as well as commercial challenges that you have to deal with. And like anyone who thinks about climate change, or like you think about pollution, you think about cars, you start with the EV sector. But eventually I realized that I want to focus on problems that not that many people are focusing on, and are also extremely, extremely difficult to solve for. If you think about shipping, for example, you have a massive ship. The land footprint of that ship would be bigger than this building. And you have to figure out how to design that ship, how to think about the engine, how do you think about the fuel, and then how does it actually help you take your cars, your iPhones, whatever that is, from let's say Tokyo to like San Francisco. And so these are like very complex problems, takes years to solve for. And my role has allowed me to like understand the technical side as well as the commercial side. So if any of you are thinking about working in climate change, solving for those problems, feel free to reach out to me anytime. I'm pretty sure there's no other Rachit Kejriwal on LinkedIn, so should be able to find me. And yeah, I'll pass it back to Kawanaka-san to introduce more about MOL and the work we're doing here.
Before jumping into the technical presentation, I'd like to briefly introduce MOL, what we are doing. Yeah, we are the shipping company. We transport goods, bulk cargoes, and energies, and we have a quite long history. We established a company more than 140 years ago. Yeah. Currently, we're operating close to the 900 vessels in the globe, which is, I think, one of the biggest shipping company in the world. Yeah. And we have a quite large numbers of people working in Tokyo, Japan, and also US, Europe, other countries in Asia, India, almost all over the world. Amount of the numbers of the employee we have is about 9,000. And numbers of country we are based on is, I say, you can see the 44. So you can imagine that we are quite globally distributed and we perform the businesses quite globally. Yeah. And today's topic is really related to the net zero emission from the industry. So we are the shipping industry, and the shipping industry, under the international regulation, we call it the International Maritime Organization's regulations. Under this leadership that we are aiming to achieve the net zero emission from the shipping services by the end of that 2050. So today's presentation is part of the program we aim for the net zero emission from the shipping services. Yeah. This is a snapshot, what type of the vessels we are operating. You can see blue one, this is dry cargo businesses. We carry grain, iron ore, coal, and also we transport the energy like a crude oil, liquefied energy, and any other mode of the energy is transported by the vessels. And also, you can see the purple, on top of the transport of the bulk cargoes and energy cargoes, we are transporting the, a product, goods, by means of the container shipping and also the car carriers which transport the cars in the big ships. Yeah. So gradually, I'd like to move on to today's topic. The shipping industry is not too familiar with many people indeed. Yeah, to be honest. Yeah, but probably people is going to think about ship is so big. That's why we consume quite high volumes of the fuel, energy, and we have a quite high emission from the vessels. So people may think that we are the big polluter in the world. But I like to say this is not really true, yeah, because if we see the energy consumption of the every mode of the transportation, shipping is really environmental friendly. Yeah, when it comes to the situation that we see that the consumption of the energy, like grams of the fuel oil per tons of the cargo and that per kilometer, which is the distance. I mean that if we transport the same weight of the cargo with the same distances, ship is the most efficient means of the mobility. Yeah, like you imagine that, of course, aviation is not too efficient. Yeah, because aircraft doesn't carry too much of the cargoes. Yeah, but although, yeah, I like to say that shipping is already efficient in terms of the emissions. But I like to say that we have to aim that the net zero emission from the shipping services as well towards the end of the 2050. Yeah. Then this is the beginning of my today's hot presentations. You can see the vessel on the sea, and you can see the sail, big sail at the front of the vessels. So I'd like to say welcome to the new era of the shipping, and let me continue. Yeah. If we see the global activities and ambition that towards the reduction of the greenhouse gases, you can see that for instance, 1997 in Japan, the global countries announced the Kyoto Protocol, which is, I think, the substantial start of the thinking about the decarbonization for the future. And our challenge, Wind Challenger project starts after the Kyoto Protocol and before the Paris Agreement. Yeah. So I like to say that the why we start this program is that initially we are thinking that this program, these challenges will contribute of the saving of the fuel. Saving of the fuel means saving the money we spend. Yeah. But time has changed. And now that we are all think about the net zero emission, decarbonize, yeah, reduce the global gas emissions from the industries. So that's why nowadays our technology is more focused for the purpose of the reduction of the greenhouse gas emission from the ships. Yeah. But I'd like to say that the net zero emission of the shipping service is really difficult to achieve. So many people say that the shipping and aviation is most hard to abate business sector when it comes to the decarbonize of its businesses. Yeah, the reason why, because technically we already have like a hydrogen-based fuel, liquid hydrogen, ammonia as a hydrogen carrier. This is already technically available, but this costs a lot if I compare to the existing crude oil-based fuel of the maritime. Probably the price of the new generation green fuel is more than 3 times higher than that. Yeah, and also you can see in the left that the lower energy density. Yeah, compared to the oil, these hydrogen-based fuel has a less energy density per cubic meter, for instance. That's why, in short, we need to secure the large spaces on board to store the energy to propel the vessels, which means we have to use many spaces for just keeping the fuel. Yeah, we really want to carry the cargo. We don't really like to carry the fuel only. That's why this is really the challenges. Yeah, that's why we are thinking that first things we have to think about towards net zero emission of the shipping is to try to minimize the consumption of the energy as much as possible. Yeah, there are many technologies. And today I'd like to introduce one of that we are very ambitiously trying to achieve. Yeah. Yeah, before coming to the more detail, I'd like to touch upon the history of the ships a little bit. In all the ages, wind is propelled by the wind sail only. Yeah, there was no engines on the vessels. Yeah, but it's less efficient, less speed. Yeah, and after the 19th century, we start to utilize a steam turbine, and the fuel of the steam turbine was a coal. Yeah, but nowadays we don't use any coal for the propulsion of the vessels. We changed to the heavy fuel oil, which is a part of the crude oil, with the diesel engine technologies. And recently, we are gradually starting the alternative fuel, particularly liquefied natural gas, which is a cleaner fuel compared to the crude oil-based fuel. Yeah. But technologies we have made for the purpose of the reduction of the fuel consumption and the energy emission from the vessel is mainly happens underwater of the vessels. This red dotted line is the water line. Yeah, and in the history, many engineers try to make every effort to minimize the reduction and minimize the friction of the drag, whatever the things, in order to reduce the resistance on the hull. And also engine technology has been developed from steam turbine to the diesel engine. Everything happened under the water. But do you see, is there any room for the further improvement for the shipping technologies? Yeah, we are thinking that why don't we think about the spaces above the waterline? Yeah, that's again the wind. Yeah, I mentioned that being that we in ancient years we used the wind power for propel the vessels. Yeah, let us think about the wind power again. Yeah. Yeah, that's why a way of thinking is that, of course, we maintain the existing ships technologies, but on top of that, if we have a set of the wind sails like this picture, what happens? Yeah, how much savings we can achieve? Let's imagine. Yeah. So we started with this concept, initially the research and the development program. Yeah. And initially in Japan, the program was launched under the name of the Joint Industry Project. And the leader of this JIP was Tokyo University in Japan. And several industry players, including MOL and also other shipping company, manufacturer related to the shipbuilding, joined the program in order to launch the wind sail technologies in the shipping industries. Yeah, you can see the videos. Yeah. Sorry, today I have videos, but no no music. But I'm going to explain that what's going on. Yeah, this is an onshore-based trial. What's happened if the wind sail like that is moving and how the effect will be. Yeah. So initially, more than 7 to 8 years, university lead, JIP, has made some achievements. Yeah. But unfortunately, the many partners, our competitors in Japan and manufacturers has less JIP because in those ages, people doesn't really feel that this technology will fly. Yeah. But we're thinking that this project was too good to terminate. Yeah. We are thinking that we should see that more high expectation that we can use wind power for the vessels. Yeah. That's why we have decided, yeah, we take a championship to continue this program. Yeah. And I like to say this is the start of the suffering and seeing the many programs, yeah, towards the achievement. I can explain later on. Yeah. And after the research and the development phases, of course, we need to jump into the design and engineering phase. Yeah. So JIP may brought some ideas and some outcome, but this is just a on-land basis demonstration of the wind sail. But we are operating the vessels. Yeah. Sea environment condition is more tough compared to the onshore environment. That's why, for instance, we have to think about what the behavior of the wind sail if we install the wind sail on the vessels, because ship is always exposed to the heavy wind and wave, and the ship is always moving like that. Yeah. And we want to really carry the cargo. We don't like to the steel product. That's why we have to think about the reduction of the weight of the steel. This is another challenge. Yeah. And also, in the shipping industry, shipping company always have to take an insurance of the services from the insurance company. In order to have an insurance from the third party, we need to assign a certain certification body to really make sure that this product is really okay from the safety point of view. That's why we have to engage. We call it the classification society, which certifies the project for the maritime use. Yeah. And the design and engineering, we have a quite nice means of the calculation, like a computational fluid dynamics. You can see at light top. Yeah. And also, structural rigidness is quite important. So we have carried out the calculation to estimate how rigid enough our cell is. Yeah. And also, calculation is not good enough in many cases. That's why, in order to evaluate how the efficiency of the wind sail is, that we have carried out the wind tunnel test in order to visualize the airflow like that, and also estimate and calculate the lift which activated on the sail. You may imagine that the wind sail is quite exactly the same as the features of the aircraft wing. Yeah. And having carried out those calculations and the wind tunnel test, yeah, we come to the theoretical conclusion that, yeah, what wind condition is the best fit for the purpose of saving the energy of the ships? In short, I'd like to say that if we have a wind from the left or the right relative to the vessels, this is most efficient. Yeah. More specifically saying that, for instance, if the wind is coming from the head, from the front of the ships, we don't really expect the improvement of the efficiency. Yeah, we are not really achieve the lift from the sail. That's why if we have a headwind, we don't use the wind sail. Just try to make the position of the wind sail in the picture in the left hand, and also the wind sail is lower down in order to minimize the drag caused by the wind sail. But if we see the lateral wind, we start to operate the wind sail like that, And we are assuming that the big lift is happening on the wind sail, and this thrust is going to help to propel the vessels. And the engine propulsion power is going to be reduced. So we can minimize the consumption of the energy, which is consumed by the engines itself. Yeah. And on top of that, I want to say that the material is quite important to make it, the product is cheap, light as possible. Yeah. So we come to the conclusion that we may probably be able to use the FRP, fiber reinforced plastic. Yeah. Weight of the FRP is much less than the steel or any other metal product. Yeah. Then we can imagine that. Yeah. Where the FRP has been already used on the vessels. This is one of the vessels we operate, which is a very large crude oil carrier. Length of the ship is 300. Yeah, quite big ship, mostly steel made. FRP is only used for this area. This is a kind of rescue boat for the purpose of the people working on the vessel to evacuate from the ships if the incident happens. Yeah, that's it. Yeah. So you can imagine that the most of the material we use for the ship is steel-based. Yeah. So that's why, yeah, we try to challenge that FRP used for the other parts of the vessels, Wind Challenger. And this is just a video showing that how the FRP-based component of the wind sail was made. Yeah, plastic was injected in the mold made of the fiberglass. And I think we have exercised many trials in order to ensure the quality, strength of the components of the wind sail. Yeah. And after that, each component needs to be assembled in the subcomponents, like this video shows. So this demonstration was made in a certain shipyard. This shipyard is collaborating with us to build this Wind Challenger. Yeah. So we find it that the assembly of the plastic-made sail is okay. Yeah, we can achieve that. Then this is a milestone for the next more big assembly of the sail. Yeah. But in the meantime, yeah, because this project is a quite MOL-oriented project, so we really need to have our management understanding of the project. Yeah. So while we are making this trial to make a sub-assembly of the components of the wind sail, yeah, our chairman of the board visited the site, yeah, and he has aspired that what we are doing, yeah, so nicely. And in the meantime, we have internal kind of the college for the young colleagues in working in MOL to do the presentation in terms of the management of the future MOL, yeah. And I forget about the year of this program, but in a certain year, the title and the theme of the program was sustainable shipping. And one of the guys proposed that why don't we use this technology into the more real and the big scale? And this presentation made by the certain young guy was really motivated, really encouraged by the management people. And management has realized that we technical people might have been doing very well for the future technologies. So management starts to support. This moment was great. Without having that, I don't really think that we can move further. Yeah. And finally, engineering drawings has been completed, 60 drawings for the purpose of the construction of the wind sail entirely. Yeah. And on top of the manufacturing of the sails, it is really important for us to how efficiently we can use this wind sail. I mean, a control of the wind sail according to the weather and the weather forecast. Yeah. So we have made together with a certain IT system vendor that how we're gonna nicely control the wind sail according to the weather and the weather forecast. And more importantly, yeah, we are saying that the weather routing, if we say, yeah, if we just transport from the A to B, we usually take a great circle, which is a shortest distance between A to B. Yeah, But now we are trying to use the wind power as maximum as possible. That's why, ideally, we really want to catch a nice wind, lateral wind, as much as possible. Then a simulation showed that the suggested course, like a blue here, even though this deviates from the great circle a lot, probably taking the course like that is more saving the energy. That's why we introduced this kind of weather routing system on the vessels, and this has already contributed a lot to really see the savings of the energies and the emission reduction. And this is towards the last moment of the presentation. So you could see in the previous slides that the sub-assembly of the part of the components of the wind sail. This is a full-scale assembly of the wind scale. This is a shop in the shipyard, so we need a big spaces. So without having the collaboration with the manufacturer, we are not really able to achieve these challenges. So we need partners, certainly, because we are a shipping company, we are not a manufacturer. And this is the wind challenger actually installed on the vessels. And initially, we tested everything at the ground of the shipyard, up and downs and the rotate, everything we confirm. And after that, we're actually going to install onto the vessels. Vessels are constructed on the dry dock in the shipyard. And if the vessels are mostly constructed, we are going to install this wind sail at the fore. And we have actually retrofitted the wind challenger on the vessels. It's a time to see the results. This is a sailing trial. We tested the sailing system. Mechanisms, all mechanisms, very well working in the sea. This is a trial demonstrated before the ships are delivered from the shipyards to MOL. Our people joined together with the shipyard people and confirmed that the system is working quite nicely. And I have to say that in actual weather conditions, we operate the vessels. This is not a calm weather at all. We mostly encounter the heavy waves during the sea passages. You can see the picture right, that this vessel having the wind challenger encountered a very rough sea on a certain day. And you can imagine that the wind challenger, this wind sail, is exposed to the high waves. So as I mentioned at the beginning, that wind sail should be rigid enough. And if we operate the vessels in a cold and icy environment, icing happens on the structure of the sail. Bit difficult to see, but the picture left shows that the icing happened on the components of the wind sail. So wind sail needs to be good enough to operate even in icy conditions as well. And how much saving we could achieve. This is one of the results. This graph shows the 24 hours in a certain day. As far as I remember, that this is one of the day where the vessel is sailing from in the Indian Ocean. And we relatively have a nice wind. You may see in the diagram in the right side that this is a chart indicating the wind direction and the wind speed. You can see that wind is mostly coming from the left side of the vessels, and the wind speed here is above 10 meters per second. Maybe average speed is around 13 to 14 meters per second. This is relatively nice wind condition for this wind challenger. And how was the result? This is graph left is a time lapse evaluation of the energy saving. Of course, wind is changing moment by moment. That's why that the reduction of the emission, I mean the energy saving, is not constant at all in a day. So the reduction saving is fluctuating all the time. Yeah. I like to say, if we take an average, you can see the horizontal red line, average saving was, in this case, is 70%. This is big indeed, yeah. And at the high peak, even though this is just a moment, like 3 minutes or 5 minutes, we could see 30% savings, yeah. I don't like to say the 30% is kind of the representative numbers for the saving, but at least I like to say that the more than 10% saving is expected from technologies. Now, just second vessel having the Wind Challenger was delivered last month. Yeah, yeah. This is a video showing the Wind Challenger. This vessel is relatively smaller compared to the first vessels. That's why this size of the sail is slightly smaller, because we don't need to have a big sail, too much big scale sail on the small scale vessels. Yeah. Yeah, and this is almost last pages of my presentation. So for the moment, we only have 2 vessels with a Wind Challenger system. But our target is that by the year of 2030, we really want to have at least 25 vessels with the Wind Challengers, yeah, for MOL on fleet. But I don't think that this is good enough for us, because we need more production in order to mature the more technologies. And also, if we construct more Wind Challenger, we can expect a reduction of the cost price of the wind sail. So I really wish to expand these technologies to more wider scale. Ideally, want to sell somewhere else, some other shipping company as well. Yeah, so key takeaway for today from my side is, I'd like to say, although shipping is considered to be the already technology matured industry, but I want to say that there is still room for the further innovation in our industry. We can find it, you can find it, yeah. And Wind Challenger is a great example of user-driven development, because we are user of the technologies, yeah. We are not manufacturer, but sometimes user can drive the technology project as well. Finally, yeah, I think if we try to make it happen in a real, we really need support from the various stakeholders internally and externally. Like what I mentioned, that the management support at certain moment to drive this project further. So communication with potential stakeholders are quite important, even internally, in order to make the ambitious challenge in a real, yeah. So this is, I think, end of my presentation. And finally, this is a QR code. If you can access that, you can see our companies more in detail, what services, what technologies that we are looking at. So thank you very much. Thank you very much.
Thank you so much for that great presentation. We're going to start with some virtual questions, and then we'll move to in-person. Our first question is, can MOL's technologies be implemented in ships that are not using cargo? For example, cruise ships.
We are now operating one cruise ship, and we are going to have a second one within this year. Compared to the cargo transport businesses, our cruise businesses is still minor scaled. But we have a good ambition, high ambition, that we try to expand the cruise businesses as well, because things are moving, just consuming the goods, consuming the material, but entertaining the people like that. So, but because we only have one vessel for the moment, so I'm not so good at explaining what technical challenges we can have for the cruise vessels. But as long as the ship is a ship, we can have similar technologies, what we have already applied to the commercial vessels which carries the cargo. Yeah, Wind Challenger, I don't know we can take it or not because cruise ship's height is too high. If we have a Wind Challenger on top of that, it might be too high. Vessel cannot pass the bridges. Yeah. So, but on top of the wind-assisted propulsion system, we have more other technologies like injecting the air bubble at the flat bottom of the hull in order to have minimize the contact of the steel hull bottom and the water. Yeah, because water is causing the more friction, and this is a drag. Yeah, but these technologies has been introduced for the many commercial vessels and the cruise ship as well. So we can look at the more diversified technologies, of course.
Thank you. Our next question is, how sustainable is FRP? How often does it need to be replaced and or can it be recycled?
Sorry, which material?
FRP.
FRP, yeah. I think you can imagine that the FRP is already used for the aircraft, yeah. But challenge for the maritime, I mean the shipping industry, is that the ship is more exposed to the big forces caused by wind, yeah. Because air and water density is pretty much different. So forces caused by the water movement is big enough. So how we can withstand with the strength of the FRP? For instance, if we use FRP for the main structure of the vessels, I don't really see that we can survive at the sea because the vessel is too big. Too big vessel means a big ship is going to bend more. Yeah. So probably the main hull is going to be the steel material, probably. Yeah. But like this wind assisted propulsion system is a quite nice example to apply more FRP more largely.
Thank you. Does MOL offer any internship opportunities? Do they offer any internship opportunities?
Internship. We are doing an internship program in Japan, yeah, but we haven't done in offices in Americas. But I think we can think about that. Actually, yeah. Ichida-san, do you want to see? Yeah, we have a head of American businesses here today. Yeah, he thinks it should be a good idea to have an internship program in a global scale.
Thank you. We'll do one last virtual question. And does MOL have patents on this technology that would prevent other shipping companies from using it? Patents on your technology?
Yeah, basically, yeah, we compete with other shipping company. Yeah, that's why we used to think about in such a way that we don't like to use our technology. We don't like to let the other shipping company use our technologies. But nowadays, target and ambition is common for all the industry. Without having the collaboration each other among the shipping companies, industry never reaches to the target of the industry, which is a zero emission from the shipping services by the end of the 2050. So more and more in the industry, we try to communicate and collaborate each other. Many organizations has been established already, working together, think together. Yeah, that's why for this program, finally I said that my final wishes is to really sell, yeah, to have more wind challenger on the other ship owners operating vessels as well. Without having that, yeah, we really like to come to the conclusion together with other shipping company, as long as this is a agenda as a social infrastructure company.
We have an in-person question. So okay, so you talked about how you put the sails usually on the front of the ship, and I was interested, especially since it's very exposed on the front of the ship to like weather and waves, why you choose to put it on the front of the ship? What are the advantages to put the sail there?
What he said?
Sail on the front of the ship.
Why put it in the front of the ship as opposed to like maybe at the back or somewhere else? Like why is the wind challenger in the front as opposed to other locations?
Okay. the reason why we have a wind challenger at the front is we have a cargo spaces in the midship part of the vessels. Yeah. But if you see, for instance, yeah, these cases, we have a big cargo spaces in the midship, and we have to open the hatches to take a cargo and load the cargo. That's why it is very difficult to have a wind challenger in the midship for this type of the vessels. But when it comes to the different type, for instance, I showed tankers in a certain site. Let's come back to that. Yeah, here. Tankers, we don't have any opening spaces on the deck. So we can think about multiple sets of the sail in the midship part area. Yeah. So actually we are now doing the joint investigation with the shipyard that we try to have 3 or 4 sets, or maybe 4 or 6 sets of the wind sail onto the tanker.
Thank
you. So the wind challenger has like a square shape, right? Why choose that shape when a lot of smaller sailing vessels use the triangular sail?
I think because the mechanism is, which ones are good? Any moment.
You got it?
Because ideally, yeah, as I explained, that we can expect a maximum lift, I mean a thrust, if the wind is coming from the left or the right like that. And in order to catch these forces, the sails, I mean a square meter of the sail itself, if we can have a large enough, that's good. That's why we are trying to have a rectangular shape of the sail. Yeah, this is most efficient.
Hi, so I just wanted to say first that I thought the idea of using like lift, not just drag for thrust is really cool. But I also saw in one of your slides that you said you had a 17% like energy saving rate or fuel saving rate. Where's like the rest of that 83% going? Like, is this in combination with an engine to reduce the load on the engine, or is it just all by itself?
It's just the savings because of the sail, yeah. Yeah, how we, which slide? It's,
There.
This is a saving just because of the wind sail. What happens actually is that we try to reach to the certain speed, yeah. And in case we don't have any wind sail system, we have to run the engines at a certain output, yeah. How are we gonna measure the effectiveness of the wind sail is that if we reach to the same speed, if the wind sail contribute to the reduction of the propulsion power of the engines, engine output is going to be less and less. So this is just a part, I think the analysis contains some of the theoretical assumption that in case we operate just vessels without a sail, what is the saving? We can estimate based upon the actual weather we encountered with the simulation by the calculation. And we compare the result, actual results, having the wind challenger to this theoretical assumption. And this is a methodology how we're gonna evaluate how efficient we are in case we operate the vessel with a wind challenger.
So I was wondering if I were to make a long-range autonomous remote control boat, what would this be a good idea to implement? Would it be a good idea to implement this type of technology on my long-range remote control boat to improve efficiency? Why or why not?
Give me one.
I can rephrase the question.
Can you
if
say
want
again,
me to.
please?
Yeah, so if I were to make a long-range autonomous RC boat,
Autonomous.
yes.
Uh,
So would it be a good idea to implement technology like this on that or no?
and we are looking at the autonomous technologies as well for the future of the shipping. Probably the small ships moving along the coastal side, we don't really see the challenges of the autonomous operation of the vessels because operating hours is a minimum, and if something wrong happens, the rescue boat is going to be reached there. Yeah, but we are basically operating the deep sea going vessels. Yeah, you can imagine that we operate a vessel. We come to the ocean, we can't see anyone, any other ships. So if we see that situation, no one else can help us, and the vessel is autonomous, and technical problems happens. What's happened? It's a big question. So how we can ensure the safety of the vessel's operation? So I want to say that we are looking at the future technology as a autonomous shipping, but it probably a bit longer way when it comes to the deep sea ocean-going vessels. But I'm certain that the coastal vessels, technologies happens.
Yes, so maybe I can help answer this question. So I think it is a function of what is your objective is. So and the size of your ship. If your goal is to go fast from point A to point B, maybe this is less useful. But if you wanted to go long distances with a minimum amount of fuel, then this is a very helpful technology. So I think it depends on what you are trying to accomplish.
Right, I think we have a question over here, but I want to add that innovation happens in many different ways. And the fact that you're taking sail power and something as pre-existing as shipping and applying some innovation to it is just super cool. And there are so many opportunities for data science applications, whether it's wind or shipping or the sail management. There's so many applications there for data science. So.
Oh, I was wondering, so for similar like large size projects like this, does MOL typically like have separate like maybe groups of engineers prototype ideas and then fund those afterwards? Or is it typically like a whole like organization level thing where they might fund like in this instance, like a wind sail, and then the engineers decide how to prototype and develop it afterwards?
I think that's a good questions. And indeed, in the history of MOL, we had a certain but limited numbers of the milestones. We actively developed the technologies. Probably, besides Wind Challenger, probably only one or two. The reason of that is that we are not a manufacturing company. We are not a research and development institute. But as I said, sometimes as a user of the technologies, and we operate the results at the sea every moment. So user mindsets to encourage the manufacturer to really materialize more enhancement or the more innovation is quite important. So to be honest, we are not the manufacturer. That's why we have a limited resource of the technical people indeed. Yeah. I mentioned that we have almost 9,000 people in the group in the MOL, but we have technical people only probably 150. This is a maximum. Yeah. So that's why what I am thinking is that sometimes great idea comes from the certain nice guys who has a very creative, innovative. But in most cases, what most important for us is to have a network with the technologies companies and try to demonstrate these technologies on our vessels. Particularly in the US, we are so excited to see the many startups relevant to the maritime technologies as well. Yeah, so this is the most important things I'm always telling to my colleagues in order to think about the innovation of our industry and the company.
Sorry, I have two questions. So first, like, what is the cost of building the sail? And then second, how long from like start to finish, like from the idea to like the final product did it take?
Yeah, because it was a quite long journey. Yeah. I like to say, I saw you the certain videos showing the trial of fabricating the sail. It happened almost 10 years before we initially launched the actual vessels having the Wind Challenger. We spent probably 10 years starting from the Dero to the Leo. Yeah. But nowadays we have almost established the technologies how to retrofit that. That's why if we think about from now on that we want to install the same technologies on the certain vessels, maybe 2 years are good enough. Yeah.
Your motivation for building the Wind Challenger is like to make economic savings. So how do you ensure that the savings you make from implementing it is greater than the time and money spent in developing it, especially like since it was built from scratch?
Yeah. It's also a good question. So I have to accept that there are many, many competitors of the Wind Challenger. Yeah, there are similar system as well. So each guy has each methodology to measure the effectiveness. Yeah. So probably sooner or later, some independent third party needs to establish how to evaluate the savings of the energies with a kind of the common methodologies. Without having that, people may think that you are wrong. Yeah. So I think this kind of the activity is going to be start up right now. Yeah, because there are many potential wind sail technologies, not only by ourselves. Yeah. And on top of answering your question that how are we going to compete with other systems? I don't like to say that we don't need to compete. Yeah, because at this moment, this technology is not technically matured, but commercially not matured. That's why sometimes it is worthwhile for us as well to try the other technologies as well and compare with our own technologies. And this will really enhance that the further matureness of the Wind Challenger technologies. And also, if the amount of the technologies delivered to the end users like ourselves is limited, but we have access to the other technologies expecting the similar effect, why don't we take the others as well? Meanwhile, we are encouraging ourselves, increasing maturity and the scale of the production. And of course, I wish to have a Wind Challenger is going to be the mainstream of the wind propulsion system in the near future.
So considering that MOL is largely a shipping and cargo company, is y'all's main goal to become as big as possible, or rather to transform the shipping industry?
Yes. Yeah, we really want, I'd like to say first that we remains to be the shipping company. This is a certain, because we have 140 years history. But for the purpose of the net zero emissions, we need to transform our, what should I say? Businesses are businesses, but technology-wise, we really want to be one of the first movers to demonstrate the new technologies. Next things we have to certainly demonstrate is a change of the fuel to the hydrogen-based. Yeah, we are gradually starting on that, but having said so that becoming one of the first movers, what the benefit we are going to have is because some of the clients is also quite environmentally conscious. That's why they're showing the attitude of the environmental conscious shipping industry. We can really able to take the environmental cautious client and which pay sometimes a premium onto the normal shipping services. That's why I would really like to encourage my company to drive the new technologies, new fuels, whatever the things, in order to attract the environmental friendly client.
Go ahead.
How long does it take for the initial investment that is required for to put the sale on to be worth it?
Initial investment to the
Chokio. Like initial investment, yeah.
how we should define the initial investment is
Like the total cost that is required to put the sale onto the ship.
Actually we are spending not small money for the development of the technologies, and but this is our cost of the development. Yeah. But when it comes to of course, we need to think about the price of the sale. If we put all the development costs we spent in the past, the sale cost is going to be extremely high. So that's why our company has taken a decision that the research and the development cost is our cost. Yeah, don't ask the owner of the vessel. I mean, a vessel's cost is going to be the minimum, only the design, and probably design is also equalized, but the material and assembly cost is only the cost for the sale, for the commercial scale.
Thank you.
I think we're on our last question here. Go ahead.
Hello. I was wondering, like, sorry, I'm kind of blanking out. For the Wind Challenger system, when you like, what kind of boats do you expect to put on it? I mean, sorry. What kind of fuel savings are you expecting, and do you expect to like sort of like shrink the volume of the fuel tanks so that you could add in more cargo? Would you think that the Wind Challenger is a kind of technology that you would be able to rely on in the future?
Yeah, actually, of course, Wind Challenger has a certain weight, like I don't exactly remember, but probably 20 tons or 30 tons of the steel and the FRP, or even more probably, yeah. But we are basically having the very big vessels, yeah. Amount of the cargo we carry is 50,000 tons, 100,000 tons. So compared to that, the weight consumption for the Wind Challenger is a minimum, yeah. That's why I think as long as we carry the cargo with the big vessels, impact on the steel weight increase of the Wind Challenger is minimum. But when it comes to the situation that we want to install that on a small boat as well, this is not negligible. So I want to say that it depends on the mode of the transport and the size of the vessels itself. But basically, we are looking at the big vessels. Yeah.
At this time, we'd like to welcome our remote sensing t-shirt presenters. It's going to be Sahiti and Nikhil.
Hi, I'm Sahiti from the Remote Sensing for Disaster Response Group at BWSI. And I just wanted to say that I really liked your presentation and also the insight into what it takes to innovate. And also, I think the concept of blending modern technology with traditional or ancient knowledge and technology is really intriguing.
Hi, I'm Nikhil Alwani, and I'm also in the remote sensing course. I thought it was really cool how you exemplified the use of the scientific method in creating Wind Challenger. Sorry. From how you identified the problem to brainstorming a bunch of solutions, designing, testing, and then iterating all the way up to real world production. I just found that really interesting. And as a thank you for presenting to us today, we'd like to present these BeaverWorks t-shirts to you.
Yeah, that's all we have for today. Virtual students can log off. Thank you guys so much.
Thank you very much.
If you don't mind.
Okay.
So in-person students, before you leave, we're going to take a photo.